Bright Tuty. Every student matters.
Hello students, let's continue the chapter Cube and Cube Roots. Now in this video, I am going to give you a lot of practice of finding the cube roots by both the method, let it be prime factorization or let it be the estimation method that we have discussed. So let's continue the chapter. Here is one question. You can see there are many parts in this question and it is asking cube root of each of the following numbers by prime factorization method. That means each of these we have to find out cube root using prime factorization method. So the first one is 64. Okay, they have given the smaller numbers first and then the larger numbers at last. Let's try with 64. Do the prime factorization of it. We get 2 3s are 2 2s are, then again 2 we get 16, dividing again by 2 we get 8, again dividing by 2 we get 4, and then we get 2 2s are 4 and 2 1s are 2. So 1 2 3 4 5 6. In 64 prime factorization, 64 can be written as product of the prime number which is the 2 and 6 times. So 1 2 3 4 5 6. Let us try to form the pairs. So this is one pair. Let us try to form the triplets. This is the first triplet, right? A group of 3. Here it is a triplet of another triplet of 2s. So we will write 64 as 2 to the power 3 into 2 to the power 3. Now we have to find out cube root. So we will write cube root of 64 is equal to, now what we have learned that in the cube of that number will come 3 times, right? The prime factor will come 3 times, but in the cube root it will come just once. So when 2 is coming 3 times in the cube of it, in the cube root it will come just once. This 2 also is coming up 3 times, it will come here just once. So 2 2s are 4. Cube root of 64 is 4 here. Got it? So I hope this method and these type of questions we have already done. So I hope we can do all the questions easily. Let us discuss one by one all the parts. In the second one, we are given with 512. Let's try with 512. So we have 512. Let's start dividing it with 2. 2 2s are 4. Then 1 is left and it become 11. So 2 5s are 10. 2 6s are 12. Again with 2. 2 1s are 2. 2 2s are 4. 2 8s are 16. Again with 2. We get 2 6s are 12. 2 4s are 8. Again with 2 we get 32. Again with 2. 16. Again 2. 8. Again 2. 4. Again 2 we get 2 and the last one is 2. So you see 512 can be written as product of 2's. How many times? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2. So I'll write 1, 2, 3, 4, 5, 6, 7, 8 and 9. So let us try to form the triplets now. This is the first triplet, this is the second one and this is the third one. So 512 can be written as 2 to the power 3 into 2 to the power 3 into 2 to the power 3. Now in the cube root, these 2's which are coming in cube as 3 times, there in the cube root they will come just once. So cube root of 512 is equal to 2 into 2 into 2, that is 8. So cube root of 512 is 8. I hope this is clear. Let's move to the next part. In the next part, we have 10,648. Let's try the third part, 10,648. So doing it, start with 2. 2 5s are 10. 2 3s are 6. 2 2s are 4. 2 4s are 8. Clear? Now again with 2 we will divide, right? 2 2s are 4. Then here is 13. 2 6 are 12. 2 6 are 12. 2 2s are 4. Whenever you have some confusions, you can recheck your calculation. Don't do mistakes, because then again you might not know that from where the mistake has started, where you did the mistake, and you have to check it again, the complete one. So see, I have divided 2 2s are 4. 1 is left, so 13, 2 6 are 12, then again 1 left, 2 6 are 12 and 2 2s are 4. Again it is divisible by 2. 2 1s are, 2 3s are, 2 3s are and 1s are. Now 1331 is divided by 11. 11 1s are, 11 2s are and 11 1s are. Again with 11, 11 1s are 11, 1 is left, 11 1s are 11. So 10,648 can be written as 3 times 2, as you can see, right, and 3 times 11. 11 into 11 into 11. The triplets are 2 here, one is of 2 and one is of 11, right. So 10,648, its cube root will be equal to 2 into 11, that is 22. Clear? This is how we find out cube root of the given numbers using prime factorization method. Let's go with the next part, which is fourth part, and it is given as 27,000. Let's try. Trying with 2. 2 1s are 2, 2 3s are 6, 2 5s are 10, 0 and 0. Again with 2, 2 6s are 12, 2 7s are 14, 2 5s are 10 and 0. Clear what we have done? 2 6s are 12, 1 left, 2 7s are 14, again 1 left, right. So 2 5s are 10 we have done and it is 0. Again with 2, 2 3s are 6, 2 3s are 6, so it is 15 now, 2 7s are 14, 2 5s are 10. Let's try it with 3. 3 1s are 3, 3 1s are 3, 3 2s are 6, 1 is left, 3 5s are 15. Again let's try with 3, 3 3s are 9, then what is left? 2, 3 7s are 21 and 3 5s are 15. 3 again, 3 1s are, 3 2s are 6, 3 5s are 15. Then with 5 we will divide, 5 2s are 10, 5 5s are 25 and again with 5, so we have 5 also 3 times. So 27,000 can be written as product of 2 3 times, 2 into 2 into 2 and it forms a triplet, right. The second is 3 is also coming up 3 times, 3 into 3 into 3, that forms our second triplet, and 5 is also 3 times now. So 5 cross 5 cross 5 and that also forms another triplet. So 27,000 can be written as 2 to the power 3 into 3 to the power 3 into 5 to the power 3. So cube root of 27,000, I think you can all imagine, it is 2 into 3 into 5, right. So the answer is 30, right. Cube root of 27,000 is 30. Now we are going to do the fifth part. In the fifth part we are given 15,625. Let's start this one. Okay, so can it be, is it divisible by 3? Can you think of, just see, 3 5s are 15, 3 2s are 6, but then 25 is coming up. It is not divisible by 3. Starting with 5, 5 3s are 15, 5 1s are 5, then 1 is left, 5 2s are 10 and 5 5s are 25. Again with 5, 5 6 are 30, then 1 is left, 5 2s are 10, 5 5s are 25. Again with 5, 5 1s are 5, then 1 is left, it is 12 now, 5 2s are 10 and 5 5s are 25. With 5 again, 5 2s are 10, 5 5s are 25. Again with 5, 5 5s are 25, right. So just see how many times we have 5, we have 6 times. So 15,625 can be written as 5 into 5 into 5 into 5 into 5 into 5. This is one triplet, this is second triplet. So 15,625 can be written as 5 to the power 3 into 5 to the power 3. So cube root of 15,625 is equal to 5 into 5, that is 25. Clear? I hope this gives you more clarity on prime factorization method. Now we will try the sixth part. In the sixth part, the number given to us is 13,824. Let's try doing the prime factorization of it. Starting with 2. 2 6 are 12. 1 is left, 2 9s are 18. 2 1s are 2. 2 2s are 4. Clear? Again I am dividing. 2 6 are 12. 1 left, 2 9s are 18. Then 2 is there, 2 1s are 2 and 2 2s are 4. Then again with 2, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6s are 12. Again with 2, 2 ones are 2, 2 sevens are 14, 2 twos are 4, 2 eights are 16. Right, again with 2, 2 eights are 16, 2 sixes are 12, 2 fours are 8. Again with 2, 2 fours are 8, 2 threes are 6, 2 twos are 4. Right, just see 2 fours are 8, 2 threes are 6, 2 twos are 4. Again with 2, 2 twos are 4, 2 ones are 2, 2 sixes are 12. Again with 2, 2 ones are 2, 1 is not divisible, so take a 0. 16 now, 2 eights are 16. Now again with 2, 2 fives are 10, 2 fours are 8. Now 54 we have to divide, right? So I am writing here now. 2 twos are 4, 2 sevens are 14. Now again with 2, is it divisible by 2? Just pay attention. 27, no. Let's try with 3. 3 nines are 27, 3 threes are 9, and 3 ones are 3. So 13,824 can be written as, let's see how many times 2 we got. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So we'll write here 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have 3 times. 1, 2, and 3. Form the pairs now. Form the groups now, not pairs. Form the triplets. This is one triplet, this is another triplet, this is the third triplet, and this is the fourth one. So 13,824 can be written as 2 to the power 3 into 2 to the power 3 into 2 to the power 3 into 3 to the power 3. Right? So cube root of 13,824 is expressed as multiplication of 2 3 times and with 3. So 2 into 2 is 4, 4 into 2 is 8, 8 into 3 is 24. So we get 24. Cube root of 13,824 is 24. Let's do the next part. The next part here is 7th part. Okay, in 7th part we are given 110592. Clear? Let's try with 2. Let's start it. 2 fives are 10, 2 fives are 10, 2 twos are 4, then 2 nines are 18, 2 sixes are 12. Is it clear? Let's try dividing it again. 2 fives are 10, then 1 is left, 2 fives are 10, then 5 is there, 2 twos are 4, 1 is left, 2 nines are 18, 1 is left, 2 sixes are 12. Then again with 2, 2 twos are 4, 1 is left, 2 sevens are 14, 1 is left, 2 sixes are 12, 2 fours are 8, and 2 eights are 16. Again with 2, 2 ones are 2, 2 threes are 6, 16 it became, 2 eights are 16, 2 twos are 4, 2 fours are 8. Again with 2, just see it is becoming 13,824. Right, this number we have already done, just previously we did it, so let's do again, and it will be a long method in this question as the number is large. So 2 6s are 12, 2 9s are 18, 2 1s are 2, 2 2s are 4. 2 3s are 6, then 2 4s are 8, 2 5s are 10, 2 6s are 12. Again with 2, 2 1s are 2, 2 7s are 14, then we have 2 2s are 4, 2 8s are 16. Again with 2, 2 6s are 18, 2 6s are 12, so we have 17 actually, so we should do with 8. 2 8s are 16, 1 is left, 2 6s are 12, and 2 4s are 8. Now 864 we have to do. 864 will be divided by 2 like this. 2 4s are 8, 2 3s are 6, 2 2s are 4. Then with 2, 2 2s are 4, 2 1s are 2, 2 6s are 12. Then again 2, 2 1s are, with 1 2 is not divided, so 0, and 2 8s are 16. Again with 2 we will go, 2 5s are, 2 4s are. Then 2 2s are 4, 2 7s are 14. Then with 3, 3 9s are, and then 3 3s are, and 3 1s are 3. Right? So we can write 110592 as product of how many 2's we have. Just see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 2's we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Right? Then we have 3's. 3 3's. Let's form the triplets. 1, 2, 3, 4 and 5. We have 5 triplets. So we have 2 to the power 3, 2 to the power 3, 2 to the power 3, 2 to the power 3 4 times and 3 to the power 3 as 1 time. So we will write 1,10,592 is written as 2 to the power 3, 2 to the power 3, 2 to the power 3 into 3 to the power 3. So cube root of 1,10,592 is equal to 2 into 2 into 2 into 3. Right? Actually we have 4 times 2, so we have one more 2 to the power 3. So we have one more 2. Right? So we get 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 2s are 48. So what is the answer that we are getting for the cube root of 1,10,592? It is 48. Clear? Let's do the 8th part now. We are about to finish the question. We are just left with 2 or 3 more parts. So 8th part, 5th, 6th, 7th, 8th. 46,656. Let's try this one. Starting it with 2, we will write 2 2s are 4, 2 3s are 6, 2 3s are 6, 2 2s are 4, 2 8s are 16. Again with 2, 2 1s are 2, 2 1s are 2, 2 6s are 12, 2 6s are 12, 2 4s are 8. You can see it again. 2 1s are 2, then 3 is there, 2 1s are 2, 1 left, so it made this second 3 is 13, 2 6s are 12, 2 6s are 12, 2 4s are 8. Again with 2, 2 5s are 10, 2 8s are 16, 2 3s are 6, 2 2s are 4. Again with 2, 2 2s are 4, 2 9s are 18, 2 1s are 2, 2 6s are 12. Again 2, 2 1s are 2, 2 4s are 8, 2 5s are 10, 2 8s are 16. Again 2, 2 7s are 14, 2 2s are 4, 2 9s are 18. Now 729 we have to do. Let's try with 3, 3 2s are 6. Then we are left with 1, 3 4s are 12 and 3 3s are. Again with 3, 3 8s are, 3 1s are. Again with 3, 3 2s are 6 and 3 7s are 21. Then 3 9s are 27 and 3 3s are 9 and 3 1s are 3. So 46,656 can be written as product of primes. The prime numbers, the 2 is how many times? 1, 2, 3, 4, 5, 6. 6 times 2 we have and 6 times 3 we have. So we'll write it 2 into 2 into 2 into 2 into 2 into 2. So this is 6 times 2 and the triplets are 2 out of this. Then 3 also is 6 times 1, 2, 3, 4, 5 and 6. So again we have 3. There are 2 triplets more. So 46,656 can be written as 2 to the power 3, 2 to the power 3, 3 to the power 3 and 3 to the power 3. So cube root of 46,656. Can you think of it? Yeah, it will be 2 into 2 into 3 into 3. So 3 3s are 9, 2 2s are 4. 9 into 4 is 36. Right? So the answer for the cube root of 46,656 is 36. Let's try the last 2 parts now. So what is given in the 9th part? As you can think, in the 9th part we are given 1,75,616. Clear? Let's find starting with 2. Do the prime factorization of it. 2 8s are 16. 1 is left. 2 7s are 14. Then again 1. So 2 8s are 16. Now 1 is not divisible, 0 and 2 8s are 16. You can try it again. 2 8s are 16. 1 is left. 2 7s are 14. Then again 1 left. 2 8s are 16. Then 1 is there, so 2 is not divisible. 1 is not divisible by 2, so it is 0. And 16 is divisible as 8. Okay. Again with 2, 2 4s are 8. 2 3s are 6. 2 9s are 18. Then 0 and 2 4s are 8. Again with 2, 2 2s are 4. Then what we will have? 2 1s are 2. 2 9s are 18. 2 5s are 10. 2 2s are 4. Again 2. 2 1s are 2. 1 is not divisible. We'll take a 0. 2 9s are 18. Right? 1 is left. 2 7s are 14. 2 6s are 12. Again with 2. 2 5s are 10. 2 4s are 8. 2 8s are 16. Right? And 2 8s are 16. Again with 2. 2 2s are 4. 2 7s are 14. 2 4s are 8. 2 4s are 8. Let's do with 2 7 4 4 now. 2 1s are 2. 2 3s are 6. 2 7s are 14. 2 2s are 4. 2 6s are 12, then 1 is left, 2 8s are 16, then 1 is left, 2 6s are 12. With 2 again, 2 3s are 6, 2 4s are 8, 2 3s are 6. Now 3 4 3 is divisible by 7, not by 3. 7 4s are 28, 6 is left, so 63, 7 9s are 63, 7 7s are 49, and 7 1s are 7. So we have 1,75,616. It can be written as, how many times do we have 2? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. Let's write it. 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many times do we have 7? 3 times. Right? Let's form the triplet. 1, 2, 3, and 4. There are 4 triplets made. So 1,75,616 can be written as 2 to the power 3, 2 to the power 3, 2 to the power 3, and 7 to the power 3. So cube root of 1,75,616 is 2 into 2 into 2 into 7. Right? So how much do we have? 2 into 2 is 4. 4 into 2 is 8. 8 into 7 is 56. Clear? So the square root of 1,75,616 is 56. Clear? Let's do the last part now. That is the 10th part. In the 10th part, we are given with 91,125. Okay, so let's try with 3 because it is not divisible by 2. If we divide it with 3, we will write 3 3s are 9. Then 1 is there, it is not divisible, we will take 0. Then you count 11. Okay, for 11 divide 3. 3 3s are 9, 2 is left, it became 22. 3 7s are 21, and then 1 is left, 3 5s are 15. Again, let's divide with 3. 3 1s are 3, 0. 3 1s are 3, 3 2s are 6, 3 5s are 15. Is it divisible by 3 again? Just see, 3 3s are 9, then 1 will be left, 3 3s are 9. Just see, 3 3s are 9, 1 is left, it became 11. So 3 3s are 9, 2 is left. Now 3 7s are 21, 1 is left, 3 5s are 15. Is it divisible by 3? Yes. 3 1s are 3, 3 1s are 3, 3 2s are 6, 3 5s are 15. Is it still divisible by 3? Yes, it is. 3 3s are 9, then 2 is left, so it is 22. 3 7s are 21, 1 is left, 3 5s are 15. Let's do again with 3. 3 1s are 3, 3 2s are 6, 3 5s are 15. Now 125 we have got. 125 is not divisible by 3. We'll do it with 5. Okay. So 5 we are going to do with 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So 91,125 can be written as, how many times do we have 3? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 5 is coming up 3 times. Form the triplets. 1, 2, 3. So 91125, that is 91,125, can be written as 3 cube into 3 cube into 5 cube. So in the cube root of 91,125, this 3 will come up once, this 3 will come up once, and this 5 will come up once. 3 3s are 9, 9 into 5 is 45. So what is the cube root of this number? 91,125. It is 45. Clear? So this is how you find out cube root using the prime factorization method. So we have done a lot of practice. You also can take many numbers and can find out the cube root. Right? You can also check whether a number is a perfect cube or not by using prime factorization method. Let's move to another type of problems. Here there are some statements given and you have to tell true and false for all the parts. Okay, for the first part they are saying cube of any odd number is even. We have learned the property of cube, that cube of odd number is odd and cube of even number is even. Okay, can you just give me one example that is an odd number but when you do the cube it becomes even? There is no such number. So they are saying cube of any odd number is even. This is false. Right? Because we know cube of odd number is odd and cube of even number is even. Now they are saying second part, a perfect cube does not end with 2 zeros. Right? So if we go with cube, a perfect cube will have zeros as zeros as multiple of 3. Either it will have 3 zeros, or it will have 6 zeros, or 9 zeros, and so on. The number of zeros at the end will be always a multiple of 3. So 2 is not a multiple of 3, so we can't have 2 zeros at the end. So a perfect cube doesn't end with 2 zeros. This is a true statement. The next one, if the square of a number ends with 5, then its cube ends with 25. So we have to check this. It is not always true, right? Let's take one example. So for the third part, we see that if a square of a number ends with 5, so let's take one example. Just see, square of 25 is 625. Yes, it is ending with 5. They are saying if the square of a number ends with 5, then its cube ends with 25. We are going to check it for different number. Let's see, does it happen for all? So for 25 it is 625, and cube of 25 square is 625 ending with 5. Cube of 25 is 15,625 and it is ending with 25. Yes, so in this case it is true. Let's check the case for 35. Square of 35 is 1225 and cube of 35, when you calculate, it will come out 42,875. So here we see that yes, the square is ending with 5, but is the cube ending with 25? It is ending with 75, right? Not with 25. So this is not true. So the statement is false. The next is, there is no perfect cube which ends with 8. Is there any perfect cube you can give me an example of? You can think an example of that the cube ends with 8. Yeah, 2 is a number, right? 2 cube is 8. In fact, any number which will have 2 as the unit digit and we take a cube of it, we are always going to get 8 at the end, right? Any number whose unit digit is 2, its cube will always end with 8. So they are saying there is no perfect cube which ends with 8. That is a false statement. The next is, the cube of a 2-digit number may be a 3-digit number. They are saying may be a 3-digit number, cube of a 2-digit number. Can you think of any number, the cube of which we do, and it should be 2-digit, and the answer is a 3-digit number? Can the cube of 2-digit number be a 3-digit number? So let us think the smallest 2-digit number. Smallest 2-digit number, 2-digit number starts after 9. So 10 is the smallest 2-digit number. And when we do, we are checking the cube of it. So cube of 10, if we do, cube of 10, that comes out at 1000 and it has 4 digits. So how come it is possible that a 2 digits number which are greater than 10 will have 3 digit in their cube? It is not possible. So they are saying it false. The statement is false. The cube of a 2-digit number cannot be 3-digit number. It starts with 1000, right? So always will have 4 digits or more. So we'll write here false. The next part, the cube of a 2-digit number may have 7 or more digits. Okay, cube of 2-digit number may have. So we saw that it started with 4. The cube of 2-digit number, let's take the greatest 2-digit number. It is 99. This is 6th part and we are going to take 99. If we take, this is the greatest 2-digit number. If we take the cube of it, can you think what will be the answer? Just try to calculate it. The cube of 99. So the cube of 99 is coming as 970299. How many digits does it have? It has 6 digits, right? It has 6 digits. So can we think of any 2-digit number? The largest 2-digit number is having 6 digits in the cube. So we cannot have 7 or more digits. So it is a false statement. The last one, the cube of a single digit number may be a single digit number. Yes, cube of 1 is 1, cube of 2 is 8, cube of 3 is 27, which is 2 digit. But yes, they are saying that it may be a single digit number. Yes, 1 and 2 are single digit number and their cube is also single digit. So this is true, right? They are not saying must be, they are saying maybe. So yes, it can be, right? So we have done all the true and false questions with reasoning. Clear? Let's move ahead. Here there is one question. They're saying that you are told 1331 is a perfect cube. We know that this is a perfect cube. So can you guess without factorization what is its cube root? So without factorization only there is one method that I have told you, right? That is the method of estimation, making a group of 3 3s starting from the rightmost digit. So let us try that with 1331. And similarly we have to guess the cube roots of these number also, and it is already said that they are all perfect cubes. So 1331. We'll make a group of 3 starting from 1. This is 1's place. So this is one group, this is second group. What is the first group? The first group is 331, right? What can be the unit digit of a number in which cube of which if we calculate we get 1 as the unit digit, right? So it can be 1 only, right? So what can we write? We can write that the unit digit is 1, right? Because this is unit digit, here is 1. This will come when we do the cube of 1, right? When in the number the 1's digit is 1, then only when we do the cube we get 1. Now for the second group, from the second group we will receive our tens digit, and there are 2 bars, so in the cube root we will have 2 digits. So in the second group is 1 only. Can you think of any number whose square is either equal to 1 or less than 1? It is 1 only, right? So tens digit is 1. Tens digit is 1, unit digit is 1. So cube root of 1331 is 11, because at 1's and 10's place we have to place the same digits. Clear? Let's try with another questions. 4913, 12,167, 32,768. Let's try. So I'll write this number first, 4913. 4913. If I form the triplet, first will be this one and then 4 is left alone. So from the first one, just see, first group is what? First group is 913. So when do you get 3? After doing cube of which digit? You get 3. We get 3 after doing the cube of 7. Just see, 7 into 7 is 49. And 49 into 7, when you do 7 9s are 63, we are getting 3 at the end. So unit digit has to be 7. Okay. Second group is what? Group second is 4. Right. So can we think of a number? 4 lies between the square of what? 4 lies between the square of, or is it equal to the square of some number? It is equal to the square of 2. So tens digit. What will be our tens digit? It will be 2, because 4 is. So how to find the tens digit? Now we have to think of the numbers whose cube is either equal to 4 or less than 4. So just to see, cube of 1 is 1, cube of 2 is 8. Yes, 4 lies between cube of 1 and cube of 2. So we always take the smaller number, that means 1, and that becomes our tens digit. So here tens digit is 1. So cube root of, what is the number? 4913 is equal to 17, because 1's place is 7 and 10's place is 1. So 17 is the answer. Clear? Let's move to the next part, that is 12,167. So this will be one group of 3 and then 2 digits are left. So definitely two digits we are going to get in the answer. Now what is the first group? First group is 167. When do you get 7 at the end? Which is the number, which is the digit? When you do the cube of it, you get 7 at the end. Just think about it. So we know that the digit, when we do the cube of it, we get 7 at the end. It is 3. 3 3s are 9. 9 3s are 27. So unit digit is 3. Okay. You need to think that 7 will come at the unit digit by doing cube of which number. Okay. Now second, what is the second group? Second group is 12. So you have to think of two numbers whose cubes are near about 12. So we know that 2 cube is 8, right, and 3 cube is 27. 3 cube 27, 2 cube is 8. So we observe that yes, 12 lies between 8 and 27, that means cube of 2 and cube of 3, and we take the smaller number is 2. So tens digit is equal to 2. So the cube root of 12,167 is 27. Clear? So now we will do the last part, that is 32,768. Let's solve this also. We'll place the bars first. 32,768 over these three, there will be one bar starting from the rightmost place, and then on 32 there is another bar. So what is the first group? First group is 768, right? Which is the number, when you do the cube of it, you get 8 as the unit place. It is 2. 2 cube is 8. So what is unit digit? Unit digit is 8. In the second part, what is second group? Second group here is 32. Right? So for 32, you should think of two numbers whose square lie near about 32. So we know that cube of 3 is 27 and cube of 4, that is 4 into 4 into 4, that is 64. So does 32 lie between these two numbers? Yes, we can say 32 lies between cube of 3 and cube of 4. Right? So we will take the smaller number. Right? So what will be tens digit? Tens digit will be 3. So what will be cube root of 32,768? At tens place I have to write 3. At units place I have to write 8. So it is 38. I hope this gives you more clarity on this concept of estimation. First of all, make triplets starting from rightmost digit. Rightmost digit here is 8. So starting from 8, I have made one bar on 3 digits. Then whatever digits are left, let it be 1, let it be 2, let it be 3. Again you have to select them and place a bar over it. Then the number is divided here in this question in two parts. Okay, so first group is 768. Then you have to think of the last digit. It is coming up 8, which is the number when you do the cube of it, right? You get 8. It is 2. So the unit digit here will be, okay, unit digit here will be 2, not 8. It will be 2, and here also it will be 2, not 8. Okay, so unit digit is 2 here because 2 cube is 8. 2 cube is 8. Clear? Then in the second group, we thought about 32. In 32, we should think which is the number whose cube lies nearby 32. So 3 cube is 27, 4 cube is 64. So 32 lies between 3 cube and 4 cube, and we take the smaller one. So smaller one is 3. So the cube root of 32,768 is 32, not 38. Clear? So this question is clear now. So that's all for this chapter. So we have done cube and cube roots in detail, practiced a lot of questions. So that's all for this lecture. Thank you so much. Stay tuned for the next upcoming chapters.